Good scientific afternoon. We are live today going through chemistry paper 1 of your GCSE exams. Going to be helping you along the way go through biology, chemistry and physics. Today we are going to continue with chemistry paper 1 where we left off last session. If you haven't seen that already, please make sure you go across and check that out. We will just share my screen with you so that you can see what I'm seeing, and with that go from there. So last session we ended with this question: how can state B change into state C? And with this we are able to then expand from here and start looking at the next set of information. So let's zoom in a minute so you can see exactly what I'm looking at. This is the AQA past paper as well, and we will switch between them as we're going. So there will be Edexcel as well, but when we're looking at the general information, it's always the same information. It's just how the exam board talk about it that makes it different. So with this question in particular, as we were saying last time, we will skip straight to what we're being asked to do. So we look for that command word. So our command word here is what is the order for the development of the model of the atom, and it's for 1 mark. With it being for 1 mark, we can then look at the actual information that we require. So in this situation, we are looking at which one would be first, or come up first, should we say. So when we're thinking about the history of the atom, this is the billiard ball always comes first. So this was when we first thought the atom was a solid sphere, and then we discovered that it wasn't, and we started looking at what was called the plum pudding model. So the plum pudding model is a big open spherical space of positivity, and we have then electrons dotted around. And with the plum pudding model, we didn't actually know that there was protons or neutrons at this point. It was solely just these two things. So with this, then we went to the nuclear model, and the nuclear model is where we discovered the actual nucleus through Rutherford's testing. And with testing, we then were able to know that there was a solid mass in the center, and the electrons then orbited around the outside. So looking at these three, our answer would be the third one. Now, notice it's got the +4 here. That's not necessarily for every single atom. This varies, obviously, depending on the atom we're looking at. But in this situation, this is what we'd be actually discovering. Sorry, my watch is currently talking to me. And we can then start to understand that for every proton, there is an electron. Because again, when we were looking at the nuclear model, we didn't even know that the neutrons existed yet. It was solely a nucleus full of protons with the electrons then orbiting around. And this is where we then, at a later date, moved on to what is known as the planetary model. So moving us on to the next question then. As we can see, again, looking for the command word. So our command word is here, complete. It's 1 mark, and we need to choose the answer from the box. The existence of neutrons was discovered by, and would anyone like to comment and tell me what they think this actually was as the answer? Was it Bohr, Chadwick, or Mendeleev? I do believe you have to also, to comment, be signed in on your YouTube account. And if that is the case, by all means, do so. And make sure you signed up, and make sure you actually also follow for more. This is a weekly occurrence, and this will be happening all the way right up to the GCSE exams, supporting you guys. So if you are watching this today, or watching this at a later time, please share and tell friends as well, because this is free support for everyone, and this is also there to help you gain a better understanding of what to expect in your exams. So if you haven't followed already, please do, and like the work that we do. So in this situation, the answer would be Chadwick. So Chadwick is who discovered the neutrons. It was only a few years after the the model of the planetary model came about, and again, we are able to then know where we're kind of looking. Yeah, right, we're clear. So, moving us on to the next question. And remember, you can watch this back as many times as you want. The more you are seeing exam practice, the better. So, again, we've got a set of information here. I'm going to skip over that. Don't need it for the minute. Let's go straight to the question. So, which piece of equipment is labeled X for 1 mark? It is a tick box only. So, when we're looking at it, the line is obviously going to this item here. And one of the biggest things that they love to do is throw equipment questions at you. And in this situation, this would be a thermometer. Well, that was a great tick. There we go. So this is a thermometer, and that's what they would be looking at. And I will throw this out there. What is this bit of equipment named? If you'd again like to comment and tell me what you think that is, that would be amazing. And we can start to go from there, basically. Moving us on. And like I said, always keep commenting. Make sure you are signed in to do so, because that's the only way you're able to comment. So our next question, which piece of equipment is the best to use to measure volumes of solution for 1 mark? Again, it's a 1 marker. Now, for some of you, you might be noticing that there are quite a few 1 markers or multi-choice questions. This is typical of the foundation papers. And when it comes to a foundation paper, it does get more difficult as we go through, because they tier the questions to the rough grades. Obviously, you can pick up marks throughout. And in general, remember, each paper is about 60, 70 marks. You're only actually needing about 45% for a grade 4 at GCSE on all of your papers. So this is an important thing to remember, is you're not expected to get the full amount of marks correct. You are just expected to get about 45%. And on the higher, to get a grade 4, it's not even that amount. So just bear that in mind. Always check your grade boundaries with the relevant exam board, so you get an idea of what percentage you actually need. So for this question, again, we're going straight to the command word. Which piece of equipment is the best to use to measure the volumes of the solution? So we've got conical flask, evaporating basin, and a measuring cylinder. Now, this is one of them typical questions where people will go, well, when I was in school, we just poured it straight from the conical flask. And because the conical flask has measurements up the side, or well, I used a beaker and that was up the side. But the actual, if you notice on the side of the beaker or the conical flask, it actually states approx. And it's because we don't actually design them to be perfect. It's because we want people to be using the measuring cylinder. So measuring cylinders are always what we would use to measure a volume. And we can then look at how to expand that question, and they would take this information and actually start to see about, well, if we've given you a measuring cylinder, or they'll give you a question where they go, oh, here's a beaker, how can you improve that question? And they love asking you questions about how to improve your information. Does anyone have any questions so far? If you do, obviously just write them in the comments. You can be either anonymous, I believe, or you can obviously just comment. But remember, you might ask a question that others might want to ask as well. This is purely there to support you all. And I'm here to help. So if you have got any questions about any of the stuff that I've talked about so far, uh, yeah, comment below, let me know. So calculating y in table 1 for 2 marks. So this is a 1 mark for the actual equation, 1 mark for the answer. But when we are looking at this question, they will allow you to have both marks solely for the correct answer, but still always make sure you're showing your markings, your workings. So in this situation, I would go 7.6 plus 7.3 plus 7.3 volts. No, that's not correct. Plus another 7.6. And we would then be looking at dividing that entire answer by 3 because we've got 3 repeats. Now, when we're obviously looking at our repeats, it will vary from paper to paper. They might have 5 repeats, they might have 10 repeats. Generally, for GCSE, we only talk about the 3. But one of the improvements, again, that they might ask you for as a 1 mark question is, well, how can you improve this? And that would be one of these things where you would take this one step further and, well, get that extra mark. So in this situation, I would be 7, 14, 21, 6, 12, 15. So 21 plus 1.5, 22.5. 22.5 divided by 3. Let me just use my calculator because I can't do that off the top of my head. 7.5. So with our answer, we would then say 7.5 down here in the, there we go, down here in the box. Now, I do get asked this question time and time again at GCSE, and people will ask me, does it matter if you write it down in the box? Ideally, that is where you write it because that is what they're kind of looking for. But as long as they can see a definitive answer, they will generally give you the mark. So it does vary each time, but these are the kind of things that we're looking for. The next question then for 2.4. So again, going straight to the command word, it's a calculate. So calculate the temperature increase when the student adds 0.4 grams of magnesium to 50 centimeter cubed of zinc sulfate. So again, this is one of them questions where we are being asked to do a calculation for 2 marks. And with this calculation, we would obviously be looking at the temperature change. So the temperature change is 9 degrees. Our original added amount is 1.2. So we need to know the difference so that then we can change, add the additional temperature, should I say. So for this question, I would be doing the following equation. So I would be going 0.4 divided by, if you can see that green line, that's terrible. Let's switch to a different color a minute because that will make it easier. So divided by our 1.2. So that was because this is obviously what the full amount would have been. We're just trying to work out what 0.4 is. So 0.4 divided by 1.2. I apologize that that's not perfectly in line. Oh my God, I'm just pressing it repeatedly. And whatever your answer is for this, so let's put that in brackets. It's not too bad. It's been worse. And we would then times that by whatever the answer there is by the 9. So this then will give us, there we go, times the 9.0. So that will then give us the following answer of 3 degrees Celsius. So again, we would write the 3 down there if we can. And again, like I said, it might be that you have done the equation here and you've put 3.0 there. Generally, most exam boards will accept this as well as the definitive answer of your equation. So moving us on. Our next question. Command word what is the name given to a reaction which causes the temperature to increase? So this is a typical question that they love to talk about. And normally this is the kind of information that you would look at near the end of the GCSE content, especially for Edexcel. AQA might teach this earlier in the year when we're looking at rates of reaction normally. So whenever I'm thinking of things like this, endothermic sounds like the word enter, like it has the same beginning. So normally energy enters into the reaction. Exothermic sounds like exit. So therefore it's releasing energy to the surroundings. And thermal decomposition is where heat is involved in the breaking down of substances. So if we're looking at a reaction which causes the temperature to increase, we are looking at exothermic. Okay, and with it being exothermic, this is, like I said, heat being released to the surroundings, whereas endothermic, it would feel cold to the touch because it's taking energy out of your hand. And this is sometimes where people don't always realize the difference between the two, is that actually exothermic and endothermic, it is either cold or hot to the touch because the temperature change in the surroundings. Moving us on again. So The students repeat the experiment with 1.2 grams of copper and 50 centimeter cubed of zinc sulfate solution. The temperature does not increase. So the command word here is give one reason why. So this is just 1 mark, and they're wanting to know why. And this is one of these typical questions where we look at our reactivity series. And when we're looking at the reactivity series in class, you would have been shown like a long list of metals, all in order. Normally, carbon and hydrogen are positioned somewhere around there. And the teacher would have said anything above carbon, we normally use electrolysis. Anything below carbon, we would use carbon as our displacement reaction. But with this, copper is less reactive than zinc. Therefore, copper won't react. So, copper is less reactive than zinc, so won't react. And this is, I always explain this to my students as, sorry, won't react. I always think about this as in a boxing terms. When you look at the heavyweight champion, they would hold the title belt. And when we start to, if they have a competitor, if the competitor comes along and wins the fight, they then have the belt. If they're too weak, they get beaten, and the original guy continues having the belt. This is exactly the same when we're looking at the reactivity series. The more reactive the chemical, it will always take the additional stuff. Okay. Again, I want to say thank you to everyone that has come along so far to watch this. If you don't mind hitting the like button just to support, I'd much appreciate that. And if you could also follow and share, let people know that this is happening so that we can increase our community of support. Because at the end of the day, I'm doing this because I want everyone to do well. Thank you for the like there. And I want you all to succeed, and I want everyone to be able to go on to their next desired course because they've either got the 2 or 3 GCSEs that they got from this course. Obviously, combined GCSE, you get the 2 qualifications, triple science, you would get the 3 GCSEs. Most schools are doing the combined science on the basis of we combined your scores together, and therefore you get the overall grade giving you the 2 qualifications. Whereas single science, it is 3 qualifications, but you don't get the support per topic. So you could absolutely ace biology and get a really strong score for biology. Your chemistry might be weak, therefore your grade would match that equivalently. Which I'm sure if you're watching this video and you're nearing the exams, you probably already know this, or well, I'd hope you would know this already. So, structure and bonding is used to explain properties of compounds. Which group of elements does not form ions? So this is one of these typical questions where they're talking about metal atoms react with non-metal atoms to form ions, and they would want you kind of starting to imagine the periodic table. So if we quickly AQA get the periodic table up a minute, just very quickly because I forgot to upload, spin it. This is where we're looking at our then AQA periodic table. Now, the AQA is exactly the same as the Edexcel, and one of the first questions I always get before any student enters the exam is what number is the atomic number, what number is the mass number, and this is the place to look. The atomic proton number on the key is at the bottom in this scenario, which would be this one here or this one here, and the mass number is the top one. It can be either way around. It could be side by side to each other. It really doesn't matter as long as you remember the smaller of the two numbers is the number of protons, the larger of the two numbers is protons and neutrons. Therefore, it's going to be bigger because I'm counting two things instead of one. So when we're looking at our periodic table, each group obviously has a different name as well. So here on our group one, we would have our alkali metals. And for this particular question that we're looking at as well, we've got our halogens, which is our group seven. And then our group zero, this would be our noble gases. Now, whenever we're thinking about our actual periodic table, it is that our noble gases are unreactive. And when we're looking at our noble gases, they aren't going to form ions. And with that, then, that has to be our only answer. Alkali metals and halogens, again, when we look back at that periodic table, we've normally got sodium reacting with chlorine to make sodium chloride, which is the obviously table salt. But it's always funny because we throw table salt all over our food, something very edible, but at the same time, both elements that make it would actually kill you, which is never a good thing. So let's move on. Thank you for joining us, whoever just did. I'm not sure because I don't seem to see names, but give it a like if you're enjoying this. So we've got a 4 marker here this time, and for this 4 marker, our command word straight off the bat is describe. So describe what happens when potassium ions react with a chlorine atom to produce potassium chloride. Answer in terms of electrons. Now, this is a key bit of information for you here, where so many students will actually not actually talk about what is happening in regards to our electrons. So, with a question like this, we can see here the outer shells of our atoms of potassium here and chlorine here. Chlorine in group 7, therefore, has 7 protons. Potassium in group 1 has 1 electron. And if I've just said protons there, I meant electrons. I mean, easy mistake to make, but I'm only human. And on this side, notice that the charge is positive and the charge here is negative. And notice we have our dot cross diagram showing that the electron that the potassium originally had is now with our chlorine. Now, electrons have a negative charge, and our protons have a positive charge. And when we lose our electrons, we become positive because we no longer have an electron for every proton, and therefore we're no longer neutral overall. We then become either negative or positive. So if we're losing negativity, we would therefore become positive, and vice versa. We gain negativity, we become negative. And it would be like as if I was giving you a compliment and giving you a negative comment every day. You would probably feel fairly neutral about me. But if I stopped giving you negativity, you would become a very positive person, and vice versa. So answering in terms of electrons specifically. So when we're looking at this, the first thing that's happening is our proton. Why do I keep saying proton? Our potassium is giving that electron across to the chlorine atom. With giving that electron across to the chlorine atom, the potassium loses an electron. So make sure also you are being very specific. One of the biggest things people lose marks on is writing "it loses an electron." The examiner doesn't know what you mean by it, therefore you won't get the mark. So obviously, if potassium loses the electron, that electron has to go somewhere. So you could literally get all 4 marks by saying potassium loses 1 electron and chlorine gains 1 electron. Now, with this, sorry, the Lexa's buttoning. So with this gets you almost all of the marks. To get the final 4th mark, you have to say then to form ions. Or you can also say to form full outer shells. Or depending on how your lecturer or teacher, should I say, has said, you can also say to form full energy levels as well. And these are the kind of things that we are looking for in our answer. So you would get 1 mark for saying about potassium losing electrons, 1 mark for saying chlorine gains, 1 mark for any of these 3, and then you would get the 1 mark for saying about that 1 electron. I am going to leave it there for today. If you haven't already hit that like button, please do. And please share this. This is happening every Wednesday at 5 o'clock to support you guys. So if you could please share, please tell whoever you might know about this so that I can help more people. And we will carry on with this chemistry paper. Or I might end up doing a little survey or something on my social media asking people whether you would prefer a biology or a physics next time, or you can comment on here now and let me know. So I will be doing this every week, as I've said. Please make sure you follow, and I will see you all next time. Thank you very much.